Hi, in today's video we'll be talking about the kinetic theory and gas laws. So what is the kinetic theory all about? We're focusing on the kinetic theory of gases because we'll be talking about gas laws afterwards. So kinetic theory basically states that particles of matter are in constant motion. Matter is made up of particles, and then these particles are in constant motion. The theory can be modified to explain each state of matter. So the following statements are statements from the kinetic theory of matter that explains the behavior of gases. So the postulate, the first postulate states that a gas is made up of large number of molecules that moves randomly in a straight line. So gas molecules are constantly in motion, and then they move in straight lines. Uh, the second theory states that these molecules collide. There are many of such molecules that are always in motion, so we expect them to collide with themselves and then with the walls of the container. That's what the second theory, the second statement is saying. And then the third postulate, the third statement of the kinetic theory of gases, is that the volume of gas molecules are small and negligible compared to the volume of the container. So the volume of a gas is almost zero. It's approximately zero. That's what this statement is saying. And then the fourth says during collision there are no attractive forces between the molecules, and that is the molecules are completely independent of one another. So it assumes that gas molecules do not attract each other um, when they collide. And then the fifth says collisions between gas molecules are perfectly elastic. When gas molecules collide, they just rebound like elastic balls. They don't lose energy. One molecule might slow down and another molecule might move faster, but the total energy involved is usually equal. So that's what the statement is saying. And then the sixth statement said that the average kinetic energy of the molecules is directly proportional to the absolute temperature. What the statement is saying is the higher the kinetic energy of the molecules of the gas, the higher the temperature, and vice versa. One way to make gas molecules move faster is to increase their temperature, and one way to increase their temperature is to make them move faster. That's what the statement is saying. Okay, let's move on and define certain terms that will help us understand gas laws appropriately. The first is the volume of a gas. When we say the volume of a gas, what do we mean? It basically is the space that the gas occupies. But I thought we say gas molecules does not occupy any space. How are we then saying that? How are we talking about gas volume? um, the volume of the container is usually taken as the volume of the gas. So, because gases would usually fill the entire container, as you can see in this image. So, the entirety of this container is filled with a gas. So, we can take the volume of the container as the volume of the gas. So, do not forget, the volume of a gas is the same as the volume of the container that that gas is found in. And then we have different units for measuring volume. The SI unit of measuring volume is meter cube, but meter cube might be very big for laboratory work, and as such there are other units. For example, we use the decimeter cube, as you can see, and then we also use the liter. Liter measures capacity anyway, but we all know that volume and capacity are interchangeable. Is that so? And then one decimeter cube make 1000 cm cube, or rather 1000 cm cube make 1 decimeter cube, and then 1 decimeter cube is equal to 1 liter, and then 1 centimeter cube is something as 1 milliliter. These are volumes that you'll be coming across um in this concept regarding gas laws. You'll be coming across volumes in dm cube, volumes in cm cube, volumes in liter, volumes in milliliter. So it's very, very important that you are familiar with their interconversions. Okay, very well. Let's talk about temperature, another very vital term that will be coming across in this in this unit, in this topic. So temperature, we all know, is a degree of hotness or coldness of a body. Um, the There are two major units for measuring temperature: on the Celsius scale and then the Kelvin scale. Celsius scale on your screen, and then the Kelvin scale. Um, the Kelvin scale measures what we call the absolute temperature. For example, water boils at 100 degrees Celsius, as you can see, and then that is the boiling point of water on the Celsius scale. But on the Kelvin scale, water boils at 373 Kelvin. The freezing point of water, or the melting point of water, is 0 degrees Celsius, but it is 273 Kelvin, and so on and so forth. So these are two scales of measuring temperature that we come across, that we use in science. But when it comes to gas laws and the calculations that are related to it, the temperature scale we use mostly is the Kelvin scale. It's the absolute temperature. So how do you convert from the Celsius scale to the Kelvin scale? As you can see, to convert from the Kelvin scale to the Celsius scale, add 273 to the Celsius temperature, and then you get the Kelvin temperature. The opposite is true. Subtract 273 from a Kelvin temperature, and you get Celsius temperature. So as you can see in these examples, it says convert the following temperatures to Kelvin scale. First is 27 degrees Celsius. 27 degrees Celsius, just add 273 to it, you get 300 Kelvin. So it has been converted from the Celsius scale to the Kelvin scale. And then the other one is minus 10 degrees Celsius. As usual, add 273 to it, and then you get the Kelvin temperature, which in this case is 263 Kelvin. Okay, very well. Let's just move on. To convert from Kelvin to Celsius, just like I've said, subtract 273 from the Kelvin temperature. So 290 Kelvin, as you can see, to be converted to degrees Celsius, we subtract 273 from it, and then 200 Kelvin, subtract 273 from it, to get minus 73 Kelvin. So that's how we convert from Celsius to Kelvin, from Kelvin to Celsius. So most of the temperature you're going to be coming across in calculations involving gas laws will be the temperatures will be given in degrees Celsius. So you might be required in most cases to convert them to Kelvin. Okay, let's also talk about pressure. Pressure has to do with the force per unit area. If gas molecules are in constant motion, it means they will collide with the container, and then they'll collide with each other, and they will exert a force on the container. That force per unit area is called pressure. So the unit of pressure, the SI unit of pressure is Pascal. or Newton per meter square. And then there are other common units we use when we are solving problem involving gas laws. One of which is millimeter mercury. That is what you have here, mmHg. It's another unit we use when doing calculation involving pressure. We also use the atmosphere, or ATM. It kind of relates the pressure of the gas being studied being studied to the pressure of the atmosphere. And then there is torrent, and then there is bar. There are other units that are also used when it comes to pressure. So because the volume of a gas changes with temperature, changes with pressure, um, we need to define standard condition for defining the volume of a gas. So I don't know whether you've made this observation, you've observed this in the past, where you inflate a ball to a certain extent and you keep it in the sun, and then you see the ball begin to rise after some time. That's because the volume is changing. Heat causes expansion, causes matter to expand. So so the idea of standard temperature and standard pressure helps us define the volume of a gas. If the volume of a gas is affected by temperature, it's affected by pressure, then when you say 200 centimeter cube, what do you mean? Because 200 centimeter cube at a very low temperature might not be the same as 200 centimeter cube of a gas at a very high temperature. So the standard is a way of defining the volume of a gas. So with standard temperature is at 0 degrees Celsius or 273 Kelvin, and standard pressure is 1 atmosphere. It's also equal to 760 millimeter mercury or 101.3 kilopascals, or it sometimes is written as 1.013 times 10 to the power 5 pascals. So take note, these are standard conditions that are used to describe the volume of the gas. So standard temperature, standard pressure, together they are abbreviated as STP, standard temperature and pressure. Very important, take note. Okay, try answering this question, and then let's see. This is to test whether you are following, whether you followed me so far. So we can discuss your answers in the comment section.